Okay, well, so in the last class, what we discussed about the matter waves. So, matter wave means if the particle or any matter is moving with some velocity v, is having mass m, there is always existed some wave that is called matter waves. The wavelength is given by the de Broglie. It is like lambda is equal to h by momentum, that means m into v. So this is the generalized equation for any matter. If you say particularly for photons, photon, that means for light waves, photons, then lambda is equal to h by m into c. Since the velocity of the light wave is c, speed of light, that means for photon lambda is equal to h by mc. For in general any matter, lambda is equal to h by mv. And also we have derived some equation lambda in terms of kinetic energy, that means 2m into e. This is what we have seen, the relation between matter wave, wavelength of the matter wave as well as kinetic energy. Similarly, for electron, we have seen the relation 1.224 by square root of v when this is in nanometers. When electron inside a potential v, then whatever the wavelength of that electron is equal to 1.224 by square root of v nanometers. This is what we discussed about in the last class, or the de Broglie's hypothesis. After that, we discussed about wave function. That means what are the matter wave, that wavelength we derived by the de Broglie hypothesis, and what is the amplitude of the wave. That means what is a variable. That variable we have seen, it is a psi, the wave function. So it is actually varying. So what psi is? It is not a physical quantity. So it's just giving the probability of existing the particle at particular time or particular position. So this is what psi. So now since psi is not a positive always, so we take it as a psi square. This is what probability density. So this we take it for the matter waves. Okay. So that we discussed in the last class. Now Heisenberg, he is a scientist, Heisenberg. He has identified something like problem is measuring some quantities, some physical quantities. What he has observed that, for example, let's say if you take a train, so now it is changing its position. Position is changing from, it is starting from this point to this point. So it is traveling. It reaches to this point. Now, as you know the momentum of the train. So you have a mass we know and velocity of the train we know. So now it is moving. Now, if anybody wants to measure the exact position of the train, so exact position, a change in the position of the train, how we can measure? So first we have to see where is the train. So how we can see the train? Since when we can see, whenever there is a light wave incident on the train, on the body, and from that body it will get scattered. So after scattering that, it is reached to our eye or something, some instrument, then we can say the body existed at this position. Now after that it is moving. Okay. Similarly, once it is displacing from this point to this point, so we can calculate how much time it will taking place. From that we can identify what is the velocity. That means v is equal to displacement by time. That means we can measure the momentum of the train. So that we can measure the momentum. So this is what generally we used to measure. But Heisenberg is saying that like this we cannot measure this change in position and change in momentum for the small particles like electrons. So there is something like a difficulty arise to measure experimentally the values of position, changing position and changing momentum occurs. How to understand this? Why it is happening? How to understand this? So now the same concept, let us imagine that electron is moving from this place to this place. It is moving from this place to this place. Now for the same thing we apply for the electron. So let's say electron is here initially. So it is moving from this place to this place. So first, if you want to identify the position of that electron, so obviously there is a light wave should incident on it. Whenever the light wave is incident on the electron, obviously since electron is a very large, mass is very small, whenever it is interacting with the electromagnetic radiation, that means light wave, then what will happen? It takes that energy and it immediately start moving. That means it is disturbed by the light waves. So whenever it is get disturbed, that means whatever the scattered ray is coming from this one, whatever we are seeing. So by that time, whenever we see at this place here, we cannot see exactly the electron is here. So by that time electron will move this place. That means we cannot exactly measure the position of that electron. So this is what experimental difficulty to measure the position, the change in position or position of the electron. Similarly, the same thing, if it is moving with some velocity v, whenever it is interacting, whenever light is interacting on the electron, that means that velocity changes. That means because of the light rays, the velocity of the original velocity of the electron is changed. That means we cannot measure the original velocity of the electron. That means we cannot measure the original position, the momentum of the electron as well as position of the electron. This is what is Heisenberg is identified. There is an uncertainty between position, the change in position of electron and change in momentum of the electron is occurs. So that is given that in a small equation form, the minimum value of the change in position into change in momentum is equal to h cross by 2. What it is saying? It cannot be 0. This value cannot be 0. Never ever 0. That means the product of change in momentum, change in position never be 0. It has to have some minimum value. That value is how much? H cross by 2. What do you mean by H cross? H cross or H cut, we can call it as a H cut is equal to H by 2 pi. H cross is equal to H by 2 pi. That means this is equal to H by 4 pi. So this is the minimum value. So equation we can write delta x into delta p is greater than or equal to h by 4 pi. This is what Heisenberg Uncertainty Principle. That means there is uncertainty between the measuring the change in position or change in momentum. So experimentally. So that is what delta x into delta p greater than or equal to h by 4 pi. So like this, another relation we can write the change in energy. Similarly, the change in energy and the change in time, it should always equal to the h by 4 pi. So this is also relation for the Heisenberg Uncertainty Principle. So this is Heisenberg Uncertainty Principle. So basically it is like there is a problem with measuring the physical quantities like change in position, change in momentum simultaneously. Similarly, change in energy, change in time simultaneously. So that is the Heisenberg Uncertainty Principle.